Shoot.
No.
Or I mean, Valentine's Day on Tuesday.
Yeah, how she already knows she's gonna be sick. She's just.
I will be in the building. I just have a meeting all day with Mrs. Lippman and Mrs. Tolarchuk. Pick a number. Pick a number.
12.
12. Great.
You know, I was gonna pick that one.
Okay. All you have to do is draw this angle. That's it. Okay. Where do angles always start if they're in standard position? On the positive side of the x-axis, and they rotate around the origin. That's where our vertex is. And then this one is actually one that's on your unit circle, so you should know how to draw this. If it's a positive angle, which way do we rotate? Counterclockwise. And 11 pi over 6, what quadrant is that going to be in? Quadrant 4. So if I were going to draw it, make sure you draw the direction of the rotation, and then you're also going to draw the little line there. So you should have 3 arrows in every one of these pictures: an initial side, a terminal side, and a rotation. And remember, if you rotate around more than once, you need to show that little spiral that you're rotating around more than once. Okay? Yes. 14 is the one the other class did, but yes. Okay. So if I were going to draw this one, am I rotating positive or negative direction? So that is clockwise or counterclockwise? Is clockwise. So you will not have calculators tomorrow, any calculators, even the red ones. Okay, so converting to degrees is not really a great option unless you're real good at like doing all the multiplication, and probably it's not worth it. So what I would remember is, can you rotate 1/4? Yes, you can. So can I do that 13 times? Yes, you can. That's all this is saying. Okay, so I'm going to rotate in the negative direction 1/4 13 times. Pi over 4, 13 times. So let me do it over here. Okay, so negative direction would be clockwise this way. Okay, so 1/4 would be here, right? It's halfway into a quadrant. So 1/4, 2/4, 3/4, 4/4, 5/4, 6, 7, and 8/4. That makes sense. That's one full rotation, right? Okay, then 9, 10, 11, 12, 13. That's where it's going to end. So that's where I'm going to draw my line.
You got to spiral it over.
And then it's going to be spiraled once plus a little bit more. Okay, so it's going to look like this, one full spiral plus a little bit more. So no need to convert as long as you remember the what a 1/6 is, or a 1/3 is, or a 1/4 is. You can just count your way around.
So we don't need to like label the line.
No.
Wait, so like, well, let's say like you go over like 3 times, so do like 3
Yep.
spirals.
Yes, you do.
I like that question. That's a good question.
Okay, that's number 1.
Okay, hold on. What's 4? How far?
Pi over 4, 45 degrees. Or a 1/3 is, is 60 degrees, or a 1/6 is 30 degrees, right? Okay. You will have a blank unit circle. And then whatever unit circle you have on Wednesday, I will collect it and give you that same unit circle on Friday. So if you take time to fill it out, you won't have to do that both days, or parts of it, or whatever you want to write on it. You'll get that same thing back the second day.
That's so nice of you.
You're welcome. Okay, number 2. So you will only have one or the other of these. It will not be both on the test. And it's just converting degrees to radians, radians to degrees. That's it. Okay, so let's pick one of each. Pick one from the top.
34.
34. Okay, so 450 degrees. If you want to convert degrees to radians, what do you multiply by? Pi over 180. Okay, so if I multiply, I get 450 pi over 180, and we know the degrees cancel. Okay, but we can reduce, and they both have zeros at the end of them, guys. So they're both divisible by what? 10. Okay, so I'm going to make it 45 pi over 18. And what goes into 45 and 18? 9. So what's it going to reduce to?
5 pi over 2.
That's your answer.
What if you don't reduce it that much?
Then you're going to lose a point. Okay. I didn't say that. Okay, pick one at the bottom.
44.
44. Okay, so now it's a radian, 17 pi over 6. And I want to convert to a degree, so what do we multiply by? 180 over pi. All right, so when I multiply, the pi's are for sure going to cancel, yeah?
Yeah.
Now, I wouldn't, if I were you, I would not do 180 times 17. I would instead reduce What's 180 divided by 6? 30. So you can make that a 30 and then just do 17 times 30. Now what's 17 times 10? Okay, 170, and there's 3 of those, right?
Oh, that's hard.
Come on, guys. You can do this.
Rats. Wait, can you just do 17 times 10?
You can do 17 times 3 and then add a 0 at the end of it. Sure, yep.
I would just do 7 times 30 plus 10 times.
Yeah, sure. I don't care how you do it.
What?
No long division.
Is long multiplication even a term?
I mean,
Yeah, because some multiplication is very long. Some multiplication 17 times 30. That's impossible. Oh my gosh.
okay, that's it. Do we have questions? All right, if you need to do like a little work on the sides to reduce or multiply or whatever, go for it, but no calculators, okay? Third question. So now most of the rest of the stuff on the test is like our right triangle stuff. When in doubt on tomorrow's test, figure out what quadrant it's in if you can, and draw a triangle, okay? Because that's going to help with most of these questions. All right, pick a number. 18, sure. Okay.
Personally, I would have chose 20. Oh, shit.
We can choose 20.
I guess we can.
They did, I think, 12 or 14.
You know what? Let's just do multiple. Why not?
I mean, we can do either.
Let's do 20.
Okay, how about we do 20 and then we'll come back at the end if we have extra time if you want to do another one. Okay? All right. Okay, well, you know what, actually? Here's why I like 18 better. Because 18 has negatives in it.
Okay.
All right, we'll just do both of them. We'll just do both. Okay.
All right.
All right. Let's draw a picture. This point is on the terminal side of the angle, which means this is where it ends up at, which is going to help us draw the triangle. Okay, what quadrant is -3 rad 3 in?
2.
Quadrant 2. Okay, so you can just draw some arbitrary point. It does not have to be to scale, okay? And from that point, remember your right angle needs to be on your x-axis. And then we're going to connect our hypotenuse to the origin, and that's where your theta always is. Okay, so right angle on the x-axis, theta near the origin. And that point, remember, is -3 rad 3. If are they being too loud over there? I've already asked them to be quiet like twice. Do you want to go tell them to be quiet, please? Mrs. McDonald said.
Oh.
Just tell that there's a sub.
Not like
Yes. Say Mrs. McDonald would nicely ask if you could keep it down. Okay. Yes.
You have beef with them?
I don't have beef. It's
I
just
have
been a little loud.
Beef with the freshmen.
All right. Let's label sides. Which side in this picture is -3?
The bottom one.
The bottom. What side is rad 3?
The sidewalk.
The side. Okay.
Wait, how do we know that?
Is it okay?
Because you go.
Okay. So -3 and rad 3. Okay. Can you find the missing side of this triangle?
Yes, you can.
Using what? Okay. So -3 squared plus rad 3 squared equals, we'll just call it r squared. What's -3 squared? 9. What's rad 3 squared? 3 equals r squared. So 12 equals r squared. So r equals
Square root of 12.
square root of 12, which is 2 rad 3. And we have to do all the trig functions.
That's not that bad. That's cool on the side.
Okay, so now once you have the picture, sine is what, and remember, make sure you write theta next to it, is what two sides? SOHCAHTOA.
Opposite over hypotenuse.
Okay, opposite, rad 3 over hypotenuse 2 rad 3. What does that simplify to?
1/2.
1/2. Rad 3's cancel. And what's the reciprocal of sine?
Secant.
Oh, shit.
Oh, it is cosecant.
Cosecant. So if sine is 1/2, what's cosecant? 2. Okay, next is cosine. How do I find cosine? Adjacent over hypotenuse. What's wrong with that answer?
It's just a radical on the bottom.
Okay, so we're going to rationalize. We're going to multiply by rad 3 over rad 3. So now I have -3 rad 3 on top. What do I have on the bottom? Just 3. And what happens?
You get, wait, isn't it 2 square root 3 on the bottom?
You're multiplying.
No, but like the
Yeah.
bottom should be 2 square root 3 instead of just.
Oh, I set it up wrong to start. Sorry. Yeah, I forgot my 2 when I wrote down. Thank you, thank you, thank you. Okay. Got it, got it. I was like, wait, you're multiplying rad 3 times rad 3 and getting 6? That's not right. Okay. Yes. All right. So adjacent over hypotenuse. We got it. Just missed my 2. So the rad 3 times the rad 3 is 3 times 2 gives me 6. And then from there, 3 over 6, the numbers out front, reduced to 1/2. So it would just be -1 if you wanted to, rad 3 over 2. Now, what's the reciprocal of cosine? Secant. And this is where you have like a few different versions of cosine. You can flip any of those. I'm going to flip the first one. 2 rad 3 over -3, and then there's nothing to simplify. Okay, if you flip the other ones, bless you, you'd have a radical in the denominator, you'd have to rationalize. Last ones are tangent and cotangent. So how do I find tangent? Opposite over adjacent, so that's just rad 3 over -3. And then cotangent, if I flip that, will be -3 over rad 3, which is, if I rationalize, -3 rad 3 over 3, and then if you cancel your 3's, negative rad 3. So this has a lot of reducing with the radicals and stuff on this one.
Yeah, honestly, I mean, 20,
Yeah,
just
that's
throw it away.
Wait, will we just leave that for like?
Yeah.
So 20 is quadrant 1.
20 is quadrant 1. And what do you get, like, if you had to rationalize, you might have to, in that problem, do a rad 13 times a rad 3. Do you know what rad 13 times a rad 3 is?
You put it under the square root, right?
It's all under the square root.
26.
39.
Shoot.
39, rad 39.
Oh, it's times 3, not 2.
Yes.
Okay, I knew what it was
Uh-huh.
times 2.
Like, we're doing 20, like, 20 would it be this way, like, rad 13?
So rad 13 would be horizontal, and rad 3 would be vertical, and then the hypotenuse would be, you know, whatever that was. Yeah. Mm-hmm.
I mean, I don't make it like 4, 3,
Okay.
5.
Okay. Guys, here's the other thing that you can check on multiple problems on the test tomorrow. If you remember this little guy, all students take calculus. That helps you with your signs, your pluses and minuses. If I'm in quadrant 2, only sine and cosecant should be positive, which if you look at all my answers, the first 2, sine and cosecant, are the only positive answers. Everything else is negative. So I can use that to make sure I didn't forget a plus or minus sign.
Oh, that's
Kind of like a check at the end. Okay? All right, good? Okay. Next one's kind of similar. We're going to have another triangle on this one. Okay, so here we have some information about a trig function. The problem here says find all the other trig functions. It won't say that on the test. It'll actually just ask you to find one other trig function. But you still have to draw the triangle. If it doesn't tell you a quadrant, you have to figure out the quadrant. Okay, which one do you want to do? 61, sure.
Good choice.
Okay. All right, now this problem, I have a trig function, but I don't really have a whole lot of anything else. So my brain should be saying, okay, I got to draw a triangle. In order to draw the triangle, I got to figure out what quadrant it's in. And my sine is a positive number. Okay, we know that. And my tangent is a negative number. That's all that little piece is telling me. Tangent theta less than 0 means tangent's negative. So think about the little, again, all students take calculus. If sine is positive and tangent is negative, what quadrant am I in? It's got to be in quadrant 2. So we're going to have kind of a similar picture. In quadrant 2, you can pick some arbitrary point, drop it down to the x-axis, connect it to the origin. There's my theta. And we already know 2 of the sides. It might not be the x and the y, but sine is what 2 sides? What ratio? Opposite is 3. Hypotenuse is 5. And then you could use the Pythagorean theorem. This is also a triple. If you guys have done those before, remember, like 3, 4, 5.
15.
Okay, and so if you do the Pythagorean theorem, you will get a, well, technically you get a plus or minus 4, and this is where you have to be careful with these triangles. Would it make sense if I put a positive 4 there? No, it has to be negative. So you can get the positive answer with the quadratic formula, or not, Pythagorean theorem, but you need to remember when you put it in there, the context of what quadrant you're in. If you're going left, it's negative, or if you're going down, it's negative. So you want to make sure you include those in the picture. All right, now once you have that, you can literally find any trig function I ask you to do. So let's do a couple. Like, let's say the problem said find cotangent of theta. What would you say the answer is? it would be adjacent over opposite. So negative 4/3. Or if I said find the secant of theta.
Hypotenuse over adjacent.
Hypotenuse over adjacent, so
5 over 4.
negative 5/4.
Wait, why is that negative? Oh.
It doesn't matter which one's negative in a fraction.
Why does that have to be negative?
Because the 4 is
Of
negative.
course negative, because it has to be in quadrant 2, because all students take calculus.
Okay, so the problem on the test might say, here's the sign, the tangent's negative, find cotangent. Okay, it might not say find all 6, but it'll look like this. And remember, draw a triangle. Okay? Any questions?
Are we doing
It's partial credit. Yeah. Okay. All right, the next 2 questions, these look crazy, but they are just your basic unit circle questions, like what you did on your unit circle quiz. Okay, and there's going to be 2 of them, 5A and 5B, are just basic unit circle questions. They just might have some bigger angles that you might need to like get a coterminal angle for. All right, so pick one on like the left 2 columns there that you want to practice with.
37?
37, 30 what?
I think
Oh wait, what is this?
I'm liking 39.
Really?
I don't know. 38 looks good. 38.
Okay, great. 38. I heard a lot of 38s. Okay, 38 it is. All right, cotangent of 7 pi over 2. Is 7 pi over 2 on your unit circle? Is it too big or too small? Too big. So if you have a radian that's too big, what do we do? Subtract 2 pi. And what's the common denominator? The common denominator is 2, so I can think of it as 4 pi over 2. So if I do 7 pi over 2 minus 4 pi over 2, I get 3 pi over 2. Is that on my unit circle?
Yeah.
If not, remember, you can just keep adding or subtracting until you get to something that's on your circle. All right, so we know, hopefully we know that where that is, right? It's at the bottom.
Yeah.
How do you find cotangent?
That's the.
It's x over y. Okay, so at the bottom of our circle, what's the x coordinate?
Oh wait, 0.
0. And what's the y coordinate? And 0 divided by anything is 0. Okay, pick one from the right side. 78. Sure.
He was ready for that.
Okay. So we've got cosecant, I'm going to fill it in here, of 43 pi over 6. It's big. 80? Isn't that what you said? Dang it. Oh, but we already did a cotangent. Maybe that's where my brain was going. I don't know. I just guessed. I don't know. Did I say 78 and circle 80, or did I just say 80?
You said 78. It's
Sorry.
She knows what's meant.
I know. Okay. It's been a long day. I think all the debris from yesterday is in my brain. Okay, this is too big, obviously, yeah?
Yeah.
Okay, so we're going to subtract 2 pi. What's the common denominator here? 6. Okay, so imagine we're subtracting 12/6. Okay, so 43/6 minus 12/6 gives me,
31.
that's too big still. Do it again. 31 minus 12. 19, too big. Minus 12 again. 7. Ooh, that's something that's on our circle. 7 pi over 6. Okay, how do I find a cosecant?
That's 1 over x.
It's 1 over,
Oh, shoot.
Where are we getting the X in one?
You're right, it's 1 over y.
so x coordinate on our unit circle,
Oh,
cosine,
where was this?
y coordinate on our unit sine. Okay, so it's the reciprocal of the y value at 7 pi over 6. That's what we're trying to figure out, right? Okay, so 7 pi over 6, hopefully again you can locate that point. It's here. Yes. To get to that point, I have to do long, short.
Which
So
is
what is it?
negative 3 pi, or 3, square root 3 over 2.
Negative rad 3 over 2 over,
Negative 1 half.
negative a half down. But it's the cosecant, not the sine. So what do I do with that negative a half? Flip it. So my answer is negative 2.
I like when we have more than a minute to
Well, what's the negative?
Okay, so the first 2 for number 5, just straightforward unit circle questions.
Oh.
Part C on this is just a straightforward inverse function like we were doing on Friday, where you're just finding the angle on your circle. If you know nothing else about these inverse functions, guys, and this is something you could put on your circle when you get it tomorrow, you need to know what quadrants each of these inverse function is defined in. 1 and 2 is inverse cotangent, inverse cosine, and inverse secant. 1 and 4 is inverse sine, inverse cosecant, and inverse tangent. Okay? Because everything hinges on you know what quadrants these guys are at. Okay. All right, so pick a number. 40. I'll circle the right one this time. There we go. Okay.
That was a good choice.
All right. So it's inverse cosecant. Inverse cosecant of 2 rad 3 over 3. What two quadrants is inverse cosecant defined in?
1 and 4.
1 and 4. Okay, but it's a positive number, my cosecant.
So it's probably in 1.
So it's got to be in 1. All right. So 40. Okay, so that's your job now, is to figure out what angle in quadrant 1 has this cosecant. Cosecant is the reciprocal of sine, which is y. So you're trying to figure out which y coordinate on there, if I flip it, is going to look like this. It's got to be the rad 3 over 2. So which point in quadrant 1, which angle in quadrant 1 has rad 3 over 2 as a y coordinate? Pi. Okay, and guys, it's not going to say tomorrow radians or degrees, so I would be okay with either answer. Just remember, if your answer is in quadrant 4, what's special? You have to give the negative angle. Yes.
If you're like if we were doing 22,
Uh-huh.
just because it's negative, the answer doesn't have to be. The answer doesn't have to be negative, right?
For that one, it will be.
Okay, but it doesn't always
Because
have to be.
Inverse sine is defined in quadrant 1 and 4, and if it's negative, it's 4. But like, let's see if I can find one. Like this one.
Yeah.
Okay.
Just because it's negative, it doesn't have to.
Right,
Like,
because
negative, so-
inverse cosine is 1 and 2. So inverse cosine will always be a positive
So
answer.
just if it's in quadrant.
Just if it's in quadrant 4 where you have to give the negative. Yep. Okay?
Wait, you said just.
If it's in quadrant 4, like if my answer was 300 degrees,
Yeah.
just need to make it negative 60 instead.
Yes. Then that's-
Only in quadrant 4 do you have to adjust.
then
If
that's-
it's in 1 or 2, you just list what you see on your circle. All right, let's do one of these.
Okay, why is 5 so continuous?
I'm done.
I closed my 5 box. I can't do this.
Okay.
Oh, you closed. She closed the 5.
Well, that was your first mistake.
Wait,
All right.
where's our, I was the 5
What
box.
do we have?
Oh, wait.
5 has also a part E, and then number 6. And that's it.
Thank you for the warning.
You're welcome.
Really be this right.
Okay. All right,
I'll let us.
pick a number.
33.
33.
Oh, hang on a
It's
second.
more ugly.
Okay. Well, then rewrite it.
I like it.
I think I
Okay. So, well, okay. Let's talk about that one actually. What's the answer to 36?
2 pi over 3,
Why?
because the inverse is on the inside. And
The inverse is on the inside.
That's the same thing over there.
27 they would cancel. 28 they would cancel. 32 they would cancel. 31 they would cancel.
You don't have to show work for that? You
Nope.
just cancel it?
Nope.
We're not gonna get that tomorrow.
I mean, just depends what kind
You
of mood
never
I was
know,
in when I wrote your test, I guess.
Oh, I know you.
What's
I know
that
you.
ringing?
I don't know. There's like, I don't know. It's like an electrical noise that's been happening. All right, so let's write this one down. Inverse sine of 4 pi over 3. Now these could cancel, but we don't know for sure that they're going to cancel. So when in doubt, you just start on the inside and work your way out. Okay, so sine 4 pi over 3, that is just a unit circle question. Okay, so 4 pi over 3 is down here, right? What's the y coordinate?
Negative 3, we're at 3 over 2.
Negative rad 3 over 2. Okay, so the whole inside, the sine of 4 pi over 3 is negative rad 3 over 2. Okay, now it's an inverse sine question. So now we got to think about what quadrants we're allowed to get answers in. Inverse sine is in what 2 quadrants? 1 and 4. But the sign is negative. So quadrant 4. Okay, where in quadrant 4 do you have a sine, a y coordinate of negative rad 3 over 2?
Negative 60 degrees.
Negative
Please, how is that quick?
60 degrees is
I
correct.
don't know, I use it right here.
Except, hold on. This problem doesn't say what to write your answer in, but you should know what to write your answer in for this problem.
Radius.
Why does your answer have to be in radians? Because it's a radian problem. So you know it's negative 60. What's 60 in terms of radians? Negative pi over 3. And again, we only listed the negative angle because it was in quadrant 4. That's our special case.
So would you get it wrong if you said that on the test?
If you said negative 60, I would take a point off.
But on the other one, you said it doesn't matter.
I know, because there was no context about radians or degrees. This has a context, so it tells you
Oh,
what to
the
bring.
context is because it is.
Yeah, if you look at the previous problem, there wasn't a radian or a degree. The answer was that.
What if we put both?
If you put both, then your right answer is on the paper somewhere. You probably
You don't
will have.
like circle one answer?
No,
Okay.
just list both all the time, sure. Okay, last one, number 5.
Oh, yeah.
Okay. So the instructions say here to say to use a sketch. It's not going to say that on the test. You're going to have to know to sketch this, okay? And here's why you know to sketch it. Because are these numbers on your unit circle?
No.
They are not. I will tell you the biggest mistake that people make on this entire test every year is they look at this problem and they say, no solution, not on my unit circle. Okay? That's a bad idea. Do not do that, okay? Don't do that. Just because it's not on your unit circle doesn't mean it's undefined. It just means we have to draw the triangle to be able to answer the question. Okay, pick a number.
65.
65, sure. Okay. All right, sine of inverse cosine of negative 4/5. So let's start on the inside. When you evaluate an inverse function, it's an angle. There are a lot of parentheses. Okay. So we can't find that theta on our unit circle, but we can draw it by figuring out what quadrant it's in. Inverse cosine is defined in what, 2 quadrants? And if my cosine is negative, I'm in quadrant 2. Okay, draw my picture. Here's a point in quadrant 2, drop it to the x-axis, connect it to the origin, and you know the cosine. The cosine is negative 4/5. So label it. Where does the negative 4 go? The bottom. Where does the 5 go? Hypotenuse. Okay, and what's the other side? Maybe, okay, yep, maybe you see it. It's 3, or you can use the Pythagorean theorem. Yeah, and speaking of triples, we didn't put these on here, but 3, 4, 5 is one we use a lot. Also, you guys see probably a lot 5, 12, 13. And then the other one we see quite often is 7, 24, 25. It's like a fun fact. If you don't remember, it's not a big deal. You can use a Pythagorean theorem.
I learned that.
You do not have a calculator? Yeah, no, you don't have that. Okay. All right, guys. So if I take that whole inverse cosine and just replace it with theta, what it's equal to, this is what the problem boils down to. All I have to figure out, I don't know what theta is, but I can find the cosine of theta from this picture. What's the cosine? Or no, sine. It was sine. Sorry. Wrote the wrong one down. Sine was on the outside there. 3/5. Opposite over hypotenuse. And that's it. It doesn't matter what function was on the outside there. Okay? As soon as I have the triangle, I can do it. So when in doubt tomorrow, if you get totally stuck on a problem, what should you probably do? And worst case, even if you don't know how to solve it, I'm going to give you partial credit for drawing and labeling the triangle. Okay? Draw the triangle. The last problem, number 6, is the easiest problem on the whole test. Both days. All you have to do is figure out what quadrant it's in.
Oh, yeah. This is
50.
50.
good.
Okay, so again, this is a little, all students take calculus problem. Cosine of theta is less than 0 means cosine is what?
Negative.
Okay, and cotangent of theta is greater than 0 means cotangent is positive. So let's start with the positive one. If cotangent is positive, what 2 quadrants should it be in?
1 and 3.
1 or 3. Okay, because
Yes.
A means all functions are,
Oh, A is all.
yep, and then cotangent and tangent are reciprocals, so those guys go
So
together.
they count as the same thing?
Yes,
Okay.
so like the S means sine or cosecant.
Okay.
And the C means cosine or secant. The reciprocals go together. And then if cosine is negative, am I in 1 or 3?
3.
That's your answer.
Do we have to write it like that?
Usually Roman numerals are how we write quadrants. I mean, I guess you're going to take that gamble, I guess.
Guess we'll
we'll see what happens.
Guess we'll see what happens.
Depends on what they
The 1 in 4. This is basically a multiple choice question, the last one. Yes, Josh? It will look like this, where you're gonna have to name it 1, 2, 3, 4, but is that what you mean? Oh, you really won't show work for this one. Yeah, I mean, you can write that.
Oh, no, don't do that.
So this is the old one for the next.
That's it, that's what your test is. There won't be a bonus tomorrow, but that's it.
But you will put like an extra.
There won't be anything in addition to these.
No.
All right, so quick reminders. Number 1, 5-6 Math XL is due tonight if you have not finished it yet. Number 2, you guys are gonna have your video, 5th period video, both on YouTube. Plus, I'm gonna post these solutions, both in Polaris. Plus, you have all the extra practice problems with solutions in Polaris. And that's all yours to study as you like tonight, okay? And then tomorrow we'll do part 1, no calculator. Thursday we'll do the second part of the review, which is most of the graphing stuff. And you get your quizzes back for sure. And then Friday will be the second part of the test. Okay? And then next week we start something new.
Oh, man.
All right, I'll do cell phone lotto.